Welcome to Unit 9, Lesson 2, Riemann Sums. In 9.1, we learned that accumulation is just the area under the graph of our function, if our function tells us the rate of change. In the last lesson, we looked at areas that we can calculate using algebra or geometry. The problem is, sometimes the area is under a curve, is a curved line. How do we find the area under a curve, the purple one in the slide? Well, we can approximate, we can come up with a approximation. For example, an approximation for $1.99 is $2. Like 1.99 is about $2. And the area under this curve is about a certain number that we can figure out using Riemann sums. Okay. We are going to look at this function, a simple function, f of x is equal to x squared. Well, for this function, f of x equals x squared, f of 0 is just 0. F of 1 squared is 1. F of 2 squared is 4. F of 3 squared is 9. F of 0.5, that 0.5 squared is 0.25. F of 1.5 squared is 2.25. F of 2.5 is 2.5 squared, which is 6.25. We will use this to help us approximate our Riemann, to figure out our Riemann sums, to approximate the area under the curve. So here's our problem. We have f of x, which is equal to x squared. Problem. Use the following Riemann sums of 3 equal subdivisions to approximate the area under the graph of f of x is equal to x squared from x equals 0 to x equals 3. So there are 4 different Riemann sums we will learn. We have the left Riemann sum, the right Riemann sum, the midpoint Riemann sum, and the trapezoidal Riemann sum. The problem says 3 equal subdivisions from 0 to 3. We see our graph here. Here's our graph in decimals. Here is our trapezoidal sum. We are going from 0 to 3. We want 3 equal subdivisions. That means that we want to break up our area into 3 pieces. There's the one from 0 to 1, this piece, the one from 1 to 2, this piece, and the one from 2 to 3, which is this piece. Okay, in our graph. So we want to look, we're going to be making 3 rectangles or trapezoids, one of them from 0 to 1, one of them from 1 to 2, one of them from 2 to 3. X equals 2 to 3. Okay? So what are these Riemann sums? First, let's look at the left Riemann sum. The idea is this. We have 3 regions. The first region is from 0 to 1, second region 1 to 2, third region 2 to 3, right? In each region, for the left Riemann sum, we just use the value of our function on the left. Here is our step function. Here is our left Riemann sum that I've done on decimals. So what I'm doing is, from x equals 0 to x equals 1, I use a rectangle with a height equals to my function on the left. So from 0 to 1, I use f of 0. From 1 to 2, the height is f of 1. From 2 to 3, the height is f of 2. That's my left Riemann sum. Okay, this is my left Riemann sum. So from 0 to 1, f of 0 is equal to 0. From 1 to 2, I use f of 1, which is equal to 1. From 2 to 3, I use x equals to 2, f of 2, which is equal to 4. All right. So that's the left Riemann sum. So the first area is going to be the So the left Riemann sum, by the way, sum just means addition. Sum means addition. My left Riemann sum, our left Riemann sum, is just going to be the area, the sum of the areas of the three rectangles. Each rectangle has a length of 1. So we have 3 areas. Each one has a length of 1 because from 0 to 1 is a length of 1. From 1 to 2 is a length of 1. From 2 to 3 is a length of 1. Okay. Now the height is given by the value of the function on the left of the interval. Now you might say, hey, I see the screen. I see that your left Riemann sum only has 2 rectangles. So why am I saying 3? There really are 3 rectangles. It's just that the first rectangle has a height of 0 because the height is f of 0 and f of 0 is equal to 0 for x squared. Okay. The second rectangle goes from 1 to 2. For the left Riemann sum, we use f of 1 for 1 to 2. The third Riemann sum goes from 2 to 3. Sorry, not the third Riemann sum. The third rectangle goes from 2 to 3. For the left Riemann sum, we use f of 2. Okay. So it's going to equal to, I'm just going to factor out the 1 for the length of this interval. F of 0, so it's going to be 1 times f of 0 plus f of 1 plus f of 2. That's going to equal to 1 times f of 0 is 0, f of 1 is 1, and f of 2 is 4, because 1 squared is 1, 2 squared is 4. So it's 1 times 5, so it's equal to 5. So the Riemann sum, the sum of these 3 rectangles, the first one with, having no height, is equal to 5. That's the left Riemann sum. Next, let's move on to the right Riemann sum. The right Riemann sum is very similar to the left Riemann sum. In fact, I'm going to copy my paste and paste my calculations over here. What is the difference? With the right Riemann sum, the left one, well, for example, for the interval 1 to 2, for the left Riemann sum, I use f of 1. For the right Riemann sum, I use f of 2. In the interval 2 to 3, for the left Riemann sum, I use f of 2. For the right Riemann sum, I use f of 3. So let's compare the left Riemann sum and the right Riemann sum. Right? So the left Riemann sum uses the left endpoints of each interval. The right Riemann sum uses the right endpoints of each interval. So the right Riemann sum is still 1 times f of something plus 1 times f of something plus 1 times f of something, because the 1 is the length. The height of each rectangle, well, from 0 to 1, we use f of 1. From 1 to 2, we use f of 2. From 2 to 3, we use f of 3. So the right Riemann sum is going to be 1 times f1 plus f of 2 plus f of 3. f of 1 is 1, f of 2 is 4, f of 3 is 9. So it's 1 times 14, so 14. So the right Riemann sum for the function f of x equals x squared is going to be 14. Next, the midpoint Riemann sum. Well, instead of using the left or the right, here's the left again. We use the left endpoints. Here's the right. We use the right endpoints. We can use the midpoint instead. We use the value of the function in the middle of the interval. The midpoint of the interval. Okay. When we use the midpoint of the interval, there we go. The midpoint of the interval. The 3 rectangles look like this. What are we really doing? It's again very similar, but this time in the interval 0 to 1, we use f of 0.5. In the interval 1 to 2, we use the value f of 1.5. in the interval 2 to 3, we use the value f of 2.5 for our height. So our Riemann sum is going to be the length, which is 1, times the height of the three rectangles, f of 0.5 plus f of 1.5 plus f of 2.5. f of 0.5, that's 0.5 squared, 0.25. We saw that earlier. F of 1.5 is 2.25 because it's 1.5 squared. F of 2.5 is 2.5 squared, which is 6.25. So it's 1 times 0.25 plus 2.25 plus 6.25. That's going to be 2.5 plus 6.25, 6. So that's going to be 8.75. 1 times 8.75 is 8.75. Okay. So the midpoint Riemann sum is 8.75. Okay. Finally, there's one more. We can use the trapezoidal sum. The trapezoidal sum is different. In the left, the right, and the midpoint Riemann sums, we are using rectangles. The height of the rectangle depends on the function. With the trapezoidal sum, we are using trapezoids. So trapezoids look like this. It's like a rectangle, except that the height, there are two different heights. It might be going up, it might be going down. Whereas with a rectangle, it's the same height throughout. So here we have three different trapezoids. Trapezoid 1, trapezoid 2, trapezoid 3. Technically, the first one in this case is a triangle because one of the heights is 0. Okay. So to use our trapezoidal sum, well, we have the area of three trapezoids, right? I'm going to call them trapezoid 1 plus trapezoid 2 plus trapezoid 3. Trapezoid 1, well, it's going to be 1/2 times the base. For this trapezoid, we have one base and two heights. I'm just going to say that there are, so you can call them two bases, one height, or you can say one base and two heights. Either way is fine. But the point is, just to be clear, let's just say that we have two bases and one height. So here's our trapezoid. This is our height. This is base 1. This is base 2. The area of a trapezoid is 1/2 times the height times base 1 times plus base 2. Sorry, let me be more clear. It's 1/2 times the height times the sum of b1 and b2. So the area of base 1, area of trapezoid 1 has to be 1/2 times my height, which is 1, from 0 to 1. Oh, come on. Sorry about the noise. So times the two bases. The base 1 is going to be f of 0. Base 2 is going to be f of 1. That's my first trapezoid. The second trapezoid, the area is 1/2 times 1, because we're going from 1 to 2. And then we have the two bases, which is the height of the functions at f of 1 plus n f of 2. The third trapezoid is 1/2 times 1 times f of 2 plus f of 3. Okay. But we're going to factor out the 1/2. We can factor out the length of each base, 1. And what do we have? We have f of 0 plus f of 1 plus f of 1 plus f of 2 plus f of 2 plus f of 3. Right. And we can simplify that to 1/2 times 1 of f of 0 plus 2f of 1 plus 2f of 2 plus f of 3. So really, we're adding the endpoints only once and the points in between twice because we use them for two different rectangles. Okay. So that's going to be equal to 1/2 times 1 times f of 0 is 0 plus 2 times f of 1. F of 1 is 1 because 1 squared is 1 plus 2 times f of 2. F of 2 is 4 because 2 squared is 4 plus f of 3, which is 9, because 3 squared is 9. So this is equal to 1/2 times 1 times, we have 19. 0 plus 2 plus 8 plus 9 is 19. So the area is going to be equal to 19 over 2, which is really equal to 9.5. So our trapezoidal Riemann sum approximation for the area is 9.5. So this is how we can find the left Riemann sum, right midpoint, and trapezoidal Riemann sums. We're just adding up the areas of the rectangles or trapezoids, and the height is given by the value of the function. We use the left point if it has left Riemann sum, right point for right Riemann sum, midpoint for midpoint Riemann sum, and so forth. Okay. Notice that the left Riemann sum for this function, the left Riemann sum underestimates the real value. The right Riemann sum overestimates the real value, and so forth. All right, example 2. This time I'm not giving you a function. Instead, we are going to approximate Riemann sums from a table. The number of people, n of t, entering a theme park. So a theme park is, here's an example of a theme park. Let's go to Google Images. People play in these theme parks. Like Disney World is a theme park. So people are entering a theme park. The number of people entering a theme park is given by the following table. When t is 0, the number of people is 66. When t is 2, is 42. T is 4, n of t is 18. T is 6, n of t is 10. And t equals 8, and n of 8 equals 4. When t is 10, and n of 10 equals 1. When t is 12, n of 12 equals 0. So, if t is hours, that means that after the 4th hour, roughly 18 people are entering the park that hour, per hour. We're going to use the left, the right, the midpoint, and the trapezoidal Riemann sums to estimate the total number of people who entered the theme park this day. So first, the left Riemann sum. We're told that we're going to use 3 subdivisions of equal length. And we're given values for 0, 2, 4, 6, 8, 10, and 12. Well, if we want 3 divisions, we can use the division 0 to 4. That's 1. 4 to 8. That's 2. 8 to 12. That's the third one. That's 3 equal subdivisions. So, with the left Riemann sum, the first rectangle is going to have a base of 4 because we're going from 0 to 4. The height, we're going to use n of 0 because we're going to use the number value on the left. It's the left Riemann sum. Okay. The second rectangle is going to be 4 again. This time we use n of 4 because the second interval goes from 4 to 8. So the left Riemann sum uses n of 4. For the third interval, once again, go from 8 to 12. The length is 4. And then which value we use? The interval goes from 8 to 12. So the left Riemann sum uses n of 8. The left-handmost point. That's really equal to 4 times n of 0 plus n of 4 plus n of 8. That's equal to 4 times 66 plus 18 plus 4. So that's going to equal 4 times 88. 66 plus 18 plus 4 is 88. So that's going to equal, well, 4 times 100 is 4. We want 4 times 88. Well, 4 times 100 is 400. 88 is 100 minus 12. 4 times 12 is 48. So 4 times 88 has to be 352. So left Riemann sum is going to be 352. Next, the right Riemann sum. The right Riemann sum is very similar. Once again, we have 3 rectangles. Each of the rectangle has a length of 4, because from 0 to 4, the length is 4. From 4 to 8, the length is 4. From 8 to 12, the length is 4. The difference is, for the left Riemann sum, in the interval 0 to 4, we use n of 0. For the right Riemann sum, we use n of 4. For the second interval, 8 to 12, we use n of 12. For the last interval, for the second interval, 4 to 8, we use n of 8. For the last interval, 8 to 12, we use n of 12. So the Riemann sum is going to be 4 times n of 4 plus n of 8 plus n of 12, which is going to be 4 times 18 plus 4 plus 0, which is 4 times 22, which is 88. So that's the right Riemann sum. Next, midpoint sum, the midpoint Riemann sum. Again, it's very similar. We're using 3 rectangles again. 3 rectangles. Each rectangle has a length of 4. The thing is, we're using midpoints this time. So from 0 to 4, we use n of 2. From 4 to 8, we use n of 6. From 8 to 12, we use n of 10. N of 2 is equal to, so it's really 4 times n of 2 plus n of 6 plus n of 10. N of 2 is equal to 42. N of 6 is equal to 10. N of 10 is equal to 1. So the midpoint Riemann sum is equal to 4 times 42 plus 10 plus 1. That's 53. 4 times 53 is 212. Okay. Finally, we want to use a trapezoidal sum. For the trapezoidal sum, we use 3 trapezoids. Each trapezoid, so it's going to be trapezoid 1 plus trapezoid 2 plus trapezoid 3, the areas of these 3. Trapezoid 1, it has we're going from 0 to 4. Well, it's 1/2. We're going from 0 to 4, so times 4. Times, we want the 2 endpoints, n of 0 plus n of 4. Okay. Second rectangle is going to be 1/2 times 4 again, because 4 to 8 is 4. And it's going to be n of 4 plus n of 8. Third rectangle, 1/2 again, times 4 again. And this time it's going to be n of 8 plus n of 12. So that's equal to 1/2. We factor out the 1/2. We factor out the 4. And then we have n of 0 plus 2n of 4 plus 2n of 8 plus n of 12. That's equal to 1/2 times 4 times 66 plus 2 times 18 plus 2 times 4 plus 0. That's equal to 2 times, we have 66 plus 36, which is 102, plus 6, which is 108. 2 times 108 is 216. So the trapezoidal Riemann sum gives us 216 as our estimate. So about 216 people entered the theme park according to this table. Okay. Final example. Here's an AP Calculus problem. The temperature in degrees Celsius of the water in a pond is a differentiable function W of time t. The table shows the water temperature as recorded every 3 days over a 15-day period. So for example, when t equals 0, the temperature is 20. When t equals 3, the temperature is 31. T equals 6, temperature is 28. T equals 9, temperature is 24. T equals 12, temperature is 22. T equals 15, temperature is 21. Okay? So part A is a review. Part A. Part A is a review. Part A says use data from the table to find an approximation of W prime 12. Well, that's a review from section 7.2, estimating derivatives from a table. If you don't remember, you should go back and review 7.2. But the idea is we can use average rate of change. So the derivative at 12 is approximately the average rate of change from 9 to 15, which is going to be W of 15 minus W of 9 divided by 15 minus 9. So that gives us 21 days minus, so it's 21 days minus 24 days divided by 15, sorry, it's 21 degrees minus 24 degrees divided by 15 days minus 9 days. This is going to give us negative 3 over 6, which is negative 0.5 degrees per day. Okay, part B is the Riemann sum that we've been doing. Part B, approximate the average temperature in degrees Celsius of the water over the time interval from 0 to 15 using a trapezoidal approximation with subintervals of length delta t equals 3 days. Now, this is not asking us for the total. It's asking us for the average temperature. But average is just the total divided by our interval. Our total, so it's going to be the total divided by 15. So the total is going to be our Riemann sum because that's the total area. We're using subintervals of length 3 days, so that's what they gave us. So again, the Riemann sum is going to be 1/2 times the length of each interval, which is 3, times, remember that we just add the endpoints, the values of the function at the endpoints. So W of t, W of 0. The ones in between are 2 times because we add them twice. So it's 1/2 times 3 times W of 0 plus 2 times W of 3 plus 2 times W of 6 plus 2 times W of 9 plus 2 times W of 12 plus W of 15. Okay, that's equal to 1/2 times 3 times, we can do the calculations, it's going to be, so that gives us W of 0 is 20 plus 2 times W of 3, W of 3 is 31, plus 2 times W of 6, W of 6 is 28, plus 2 times W of 9, W of 9 is 24, plus 2 times W of 12, which is 22, plus W of 15. We don't multiply by 2 because that's the endpoint, plus 21. Okay. I can plug this into a calculator. So we want this one, 1/2 times this, and we get 376.5. And that's total number of degrees. But we're not finished. That's the total. The average is just total divided by interval, so it's going to be 376.5 degrees this is actually degrees times days because we're finding the area. The base has unit day and the height has unit degrees. So it's going to be 365 degrees times days divided by an interval of 15 days. 376.5 divided by 15 gives us 25.1. So our estimate using a Riemann sum for the average temperature, it's just 25.1 degrees. That seems pretty reasonable. 25 seems to be a pretty good estimate for the average. Okay. That's it for this video.